So basically we're looking at a sector OXY, which is a part of a circle with center O and has radius 9.5 centimeters, and the sector angle is given to be 53 degrees. We are asked to show the area of sector is 41.7 centimeters square. So this is a pretty straightforward question. You just need to know the formula for finding the area of a sector, which is theta by 360 into pi r square. Let me just change the pen. Yeah. Theta is 53 degrees here, divided by 360 into pi into radius is already given 9.5 centimeters. So this would be 41.7 centimeters square. That is exactly what they're asking. Next up, we have the area of triangle OAB is 1/3 of the area of sector OXY. Calculate OA. So let me just write that in a statement here. Area of triangle OAB is equals to 1/3 into area of sector OXY. So that be half into the area of triangle can be written as half BC sine A, which is basically half into take two sides and the sine of the angle between them. So I'm going to take in triangle OAB, I'm going to take OA and OB, and I'm going to take the angle between them, which is 53 degrees. So let me just write it as OA into OB into sine 53. This is equals to 1/3 into 41.74, which we've already found in the previous question. We found the area of this sector. So that be half into OA and OB are of the same measure. It's a isosceles triangle. So I can just take it as OA square into sine 53 degrees is equals to 1/3 into 41.74. So OA is equals to, when you solve this, you get 5.9 centimeters. That's the measure of OA. Next up, we have the diagram shows a sector OPQ of circle with center O and radius 24 centimeters. The sector angle is 60 degrees. And with this, they've made a cone. So using this sector, they've made a cone out of it. So when you do that, obviously the curved surface area of the cone is equal to the surface area of the sector, right? So we're just going to use that logics. Area of sector is equals to curved surface area of cone. Now that would be 60 by 360 into pi into 24 square, because the area for sector is theta by 360 into pi r square. So I'm using that formula, is equals to curved surface of area of cone, which is basically RL. That's the formula for it. L, by the way, is the slanting height. So this is L, this is H, and this is R. Yes. So here, when we solve this, we get R is equals to 4 centimeters when you solve the equation. Now we know R and we know L, because L is 24 centimeters. L is basically the radius, right? So this is 24 centimeters. We know R to be 4 centimeters. We just need height, because for finding the volume of this cone, that's the question, right? We have to find the volume of the cone. For that, we need height. So let's just use the Pythagoras theorem here. Let's just consider this triangle O. Yes, let me just name this point as D. So in triangle ODQ, OD square plus DQ square is equals to OQ square. So that would be h square plus 4 square equal to 24 square. So when you solve this, you get h equal to 23.664 centimeters. So now you have the height. You just have to use that in this formula. That would be v equal to 1 by 3 pi r square into h, and get the volume, which is 396.49 centimeter cube. This is the volume of the cone. So what we've basically done in this question is we have turned a sector into a cone. So that means the area of the sector is going to be the curved surface area of the cone. So we equated that to get the radius of the cone, because we have to know the radius and the height as well. So yeah, we got the radius of the cone. With that, we used Pythagoras theorem to find out the height, and eventually we used this formula to find the volume.